Hello everyone. Today we will be concluding our discussion of apportionment with a discussion of the quota rule and apportionment paradoxes. Now, the quota rule is essentially a rule for, in a sense, checking the fairness, you could say, of an apportionment method by essentially stating that every state should receive a number of seats that's equal to either its upper quota or its lower quota based on the standard quota. Now, if a state receives more than its standard upper quota, then we would call that an upper quota violation. If a state receives less than its lower standard quota, then we would call this a lower quota violation. So, of the apportionment methods that we've discussed, Jefferson's method can result in upper quota violations, Adams's method can result in lower quota violations, Webster's method and the Huntington-Hill method can result in either upper or lower quota violations. Another problem that we can run into with apportionment methods is what we call apportionment paradoxes. And there's three different examples of apportionment paradoxes that we'll talk about. These are called the Alabama, population, and new states paradoxes. All three of these, of the methods that we've talked about, all three of these can only occur with Hamilton's method. Now, the Alabama paradox, that you can guess which state this happened to, occurs when we have an increase in the total number of seats, and that actually results in a decrease in the number of seats that one state receives. The population paradox essentially is when one state loses a seat to another state, even though the state that lost the seat had a bigger increase in population than the state that it's losing the seat to. Finally, we have the new states paradox. This basically occurs when we add a new state with its proper apportionment of seats, and it results in a change in the number of seats that other states are apportioned. Once again, these three apportionment paradoxes occur with Hamilton's method, or can occur with Hamilton's method. They do not occur with any of the other methods that we've talked about. This brings us to the concept of Balinski and Young's impossibility theorem. And what this theorem basically states is that there is no such thing as a perfect apportionment method. Any apportionment method that you pick is going to either have the potential for upper or lower quota violations or apportionment paradoxes. Thank you for watching, and as always, I'm happy to help with any questions you have.